Students, the last session we learned about catalyst. Today we are going to discuss about colloids. What are colloids? Are they useful for us? Have you seen any of the colloid? Yes, dear students, we are dealing with a lot of colloids in everyday life, in the form of fog, in the form of smoke, in the form of your blood which is running inside your body, the food you eat, the ice cream, the shaving cream, whatever you use, most of them are made up of colloids. Are you interested to know about colloids? Come on, let us learn. So today's topic is about colloids.
We come across colloidal solutions very often in our everyday life. Some examples of colloids are milk, mayonnaise, ice cream, butter, washing up liquids and washing liquids, deodorant sprays, and atmospheric fog. Inorganic substances can also form colloidal solutions. For example, iron 3 hydroxide or Prussian blue. The striking color of red glass is due to gold particles.
First, we should understand the meaning for this term colloids. The scientist named Thomas Graham, he was trying to pass different solutions through semi-permeable membrane. As you know, semi-permeable membrane will have very fine pores, holes in it. So it allows only smaller particles through it. So he was trying to pass sugar solution, salt solution, urea solution through the semi-permeable membrane. All those occasions, the semi-permeable membrane allowed the passage of all these solutions and the particles. Later on, he was trying with a gum in water solution, gelatin water solution. This time, it was a failure. The solution, only the water content was trying to pass by the semi-permeable membrane, but not the gum or gelatin. Then the scientist Thomas Graham, he started naming the solution which were prepared with the sugar and salt as crystalloids and the gelatin and gum solution as colloids. Why he named as colloids? From the Greek origin again, kolla refers to gummy materials, and eidos refers to like. So, since they were looking like gum, they started naming them as colloids. He thought that only few materials can be in that form. Later on, some of the scientists have identified any particle or any solution which is made up of solute particles is ground to the dimension of 1 to 200 nanometers. That is diameter of the particles ranging from 1 to 200 nanometers. All those particles will come under colloids. So if you are able to grind them up to this dimension, then you can prepare colloids. Now we should understand colloids are nothing but solutions only, and those solutions most often a solid dissolved in liquid type. Most of the colloids are of that nature. But in that solution we have two types. So the colloids are classified into two components. It's a homogeneous mixture of dispersed phase and dispersing medium. So what is dispersed phase in dispersion medium? I referred colloids with the solution. For your simple understanding, you can take a sugar solution and let us compare these two. In a sugar solution, the solute particles made up of sugar comes under dispersed phase. That means which is available in smaller proportion is dispersed phase. Obviously the other one which is available in the larger proportion, most often we refer to the solvent which will dissolve the solute, will come under, most probably the water in salt solution or sugar solution will come under dispersion medium. Just for your example, you are doing your 12th standard course with English medium and a government school student may do in Tamil medium. Like the medium of study will differ, but the content is the same. Similarly here, dispersed phase will be always in smaller proportion. Just for example, I am trying to spread this chalk dust particle into the atmosphere. Chalk dust is made up of solid. That goes to the atmosphere, air. So solid dispersed in air, that is solid dispersed in gas. So the major proportion is a medium gas, but the smaller proportion is a solid. So that's how we talk about colloids. So in colloids, the main area we have to discuss is a dispersed phase and dispersion medium. If dispersion medium is water, then we have to call them as aqua salts. If dispersion medium is alcohol, then we have to call them as alcosols. If the dispersion medium, that is the solvent, is benzene, then we have to call them as benzosols. So depending upon the medium, the colloids can be classified as we discussed now. Dear students, with the solvents, the colloids can be further classified into two types. That is, one category they talk about lyophilic and the other one is lyophobic. I think from the name itself you can gain the information about meaning. Philia means love, that is attraction, and phobia means hate and aversion towards. What is the meaning of lyophilic? That is the dispersed phase, that is the solute particles, if they have greater affinity for the solvent dispersion medium, then we talk about a lyophilic type of colloids. On the other hand, if dispersed phase is having a very meager affinity, very light affinity for the dispersion medium, then we talk about lyophobic type of colloids. Example for this category, if you take a camel gum and drop it in water, and first it will go as a narrow streak of beam of a liquid, thick liquid. After some time, it will start mixing with the water. Then we can say they have a strong affinity for a dispersion medium, water. In case, if you go for a lyophobic type, that is sulfur in water, or you can take the metals, powdered form of metals, they form the solution with water. For some time they will be in the solution. Later on, time goes, they slowly come down and settle at the bottom. Precipitation may take place. But here in lyophilic type, you can add more of solvent. again you can prepare the colloid pack. So again we learn about what are colloids, why they named as colloids, and what are the different parts of a colloid which is made up of, and then lyophilic and lyophobic type of colloids we learned. Here we have to discuss types of colloids. What are the types of colloids? As I told you, colloids have two parts. It's a homogeneous mixture of dispersed phase and dispersion medium or dispersing medium. So with that dispersed phase and dispersing medium, we can classify the colloids into 8 types. What are they? We can talk about gas phase as dispersed phase. In gas, we have a liquid. In gas, dispersing medium is gas, dispersed phase is a liquid. Dispersing medium is gas, dispersed phase is a solid. Let me give you an example, you will understand better. That is, a liquid dispersed in gas. The season of Christmas and December, we can see you park your car outside your house in the night. In the day morning you get up and see, and totally it is covered with a fog. And in the atmosphere, the mist and hill station you can see. So mist is a liquid droplets in air, dispersed in air, that is gas, liquid and gas type. They call them as a liquid aerosol type. Now, solid in gas, just now I told you an example of a dust particle in the air and the smoke particles in the air. Both of them will come under solid and gas. There is one category is missing, that is gas and gas type is missing. Why this is not possible? Oxygen, nitrogen, they mix very evenly, uniformly. They form two solutions. They never form a colloidal dimension. So we don't have this category. So liquid in gas, solid in gas we have seen. Now we have to talk about the dispersion medium as liquid. One by one we will discuss gas in liquid and liquid in liquid and then solid in a liquid. So gas and liquid, this you can experience in the shaving cream. Yes, shaving cream, the froth, a foamy froth come. So this type is called as foam. And when you are using shampoo for your hair, it gives a lot of froth. And all that is because air molecules are caught inside the liquid. So air in liquid, there is air caught in the shampoo, there is gas caught in the liquid. So that is coming under foam type. Next one, liquid in liquid. For example, you take paint, for example, nowadays you see Asian Paint, Apex, they have given emulsion paint. What is the reason for emulsion? There will be a solvent liquid and they add a dye which may be having a blue color, that is also a liquid. So liquid and liquid they talk about emulsion. Simplest example is in your kitchen, milk. Yes, the fat molecules which are liquid in nature, they dissolve in water, that is major proportion in milk is water. So that comes under liquid in the liquid type. Solid in liquid type is the most available colloidal type. You are using your gel ink available for your pen. Sometimes when we talk about the solutions of juice, colored juice materials, where we add a solid into liquid. So these are the three categories where dispersion medium is a liquid. Next, we have to talk about dispersing medium as solid. Again, we have three categories. What are they? Gas in solid. Gas in solid. This is a peculiar term. You would have seen pumice stone. That pumice stone is very, very spongy and soft, and it floats in the water. The reason is there are a lot of air molecules caught inside the stone when it is being formed. Shuttlecock, for example, it floats in the water. The reason is a lot of gas molecules are caught inside the solid. Then we have this category, gas in solid type. Next is liquid in solid. So liquid in solid. If you take jelly materials, the portion of solid is more, but liquid is little. Example, curd, butter, all these things you can take as example. The solid proportion, the dispersing medium is solid, and there is availability of small amount of a liquid. If you check for this bubble gums nowadays, the inside a jelly material is paste. So the gel variety where liquid proportion will be very less. The last category is solid in solid. You may ask the question, how solid and solid can mix? And then you will see the glass materials, they have different colors. And alloys, for example, alloys gold and copper, we have stainless steel and ruby. All these materials, they are colored because some impurities also or some alloying material will be there. Then we talk about solid and solid. So, dear students, these are the 8 varieties or types of colloids we have. Types of colloids we have: liquid in gas, solid in gas, gas and liquid, liquid in liquid, solid in liquid, gas and solid, liquid and solid, and solid and solid.
When we discuss colloids, instead of solute and solvent, we will call the particulate component present in small amounts the dispersed phase, and the substance the particulate is dispersed in will be the dispersion medium. The dispersed phase and the dispersion medium can each be of any phase. Smoke is solid dispersed in gas. Clouds, fogs, and mist involve liquid dispersed in gas. Milk, mayonnaise, and butter involve liquid dispersed in liquid. Jellies and gels are liquids dispersed in solids. Foams and whipped cream involve gas dispersed in liquid. So we can see that there are quite a wide variety of colloids.
The next topic we have to discuss is about how to prepare these colloids. So, preparation of colloids. We have learned that colloidal solution are having a particular dimension, particular diameter. The size of the particles are ranging from 1 to 200 nanometer. So, we can adopt 3 methods. What are the 3 methods? First method, we are talking about dispersion method. First method is the dispersion. The second method is condensation method. The third method is exchange of solvent. All these 3 methods are very simple, and methods can be asked in 2 marks or 3 marks. So dear students, pay attention. What are dispersion methods? As you know, the colloidal particle size is intermediate between that of true solutions and huge suspensions. That means, true solution, the particle size is very, very, very small, so that they can pass through the semi-permeable membrane. Whereas in suspension, the particle size is very big. What is a suspension? Suspension may be a clay solution or a sand solution. After some time you can see all the sand and mud will come down and settle because the size of the particle is very large. Whereas in true solution, sugar solution, never the particles will come down because the size of the particles are very small. But colloidal dimension is in between these two. So we are adopting dispersion method. Dispersion method means we have to break. So you break the particle into pieces, suspension particle, then prepare the colloidal solution. So breaking and forming colloids is coming under dispersion. Then what do we mean by condensation? Condensation is the method smaller particles they join together to form colloidal particles. Then we talk about condensation. I hope you are able to understand these two terms. In dispersion we break, in condensation we join. So what are the probable methods available for dispersion? That is for breaking. The first method is colloidal mill. We'll be watching the videos for all these things. What is a colloidal mill? That you would have seen the flour mills available for the preparation of the powdered wheat or powdered, we can say the grains. We can go for a colloidal mill. But in the colloidal mill actually what happens, we are going still further grounding process, that is we are making the particle size to the very smaller size, almost 1 to 200 nanometer. How do they do that? There will be a hopper like setup. In the hopper they will place the solid particles, and then there will be two of the plates which are made up of metal. They will revolve in opposite direction around 7000 RPM. With that they revolve. During the process they adjust the gap in between the two plates so that the grinding process can be done to reach such dimension. And they will add a dispersion medium. That dispersion medium will now behave like a solvent and dissolve the solid particle and prepare the colloid. So there a solid in liquid is possible. The printing inks, if you refer to your textbook, there is then graphite ink is available that is made up of black colored graphite. This format they prepare. And the second method we are going to talk about electrodispersion. That otherwise this method is called as Bredic's arc method. The scientist George Bredick, he identified this method. He wanted to prepare the colloidal solution of metals like platinum, gold, silver, noble metals. So he placed a powdered form of all these metals at the bottom, and he used two of the electrode and stuck between the electric arc. A spark is being produced by passing 1 ampere current at 100 voltage range. During the time, large amount of heat generated near the arc. So that immediately vaporized the solid metals like gold, silver, platinum into vapor state. So all that metals in the vapor state, they come in contact with the water, that is dispersion medium, they immediately get dissolved in that solution. And to keep that liquid in a very cold condition, he was surrounding the whole setup with ice. So if you want to prepare colloidal solutions of costly metals, a colloidal solution of gold and silver, and you can go for this electrodispersion or Briggs arc method. This is one of the interesting methods.
Electrodispersion method, Briggs arc method. This method is widely used in preparation of colloidal solution of metals like gold, silver, platinum, etc. The method uses two rods of metal which we want to disperse as electrodes. These rods are immersed under the dispersion medium, in this case, water along with some stabilizing agent like potassium hydroxide. The whole setup is placed inside an ice bath or cold bath. The ice mixed with a little salt to make sure the ice doesn't melt so fast. The ice bath ensures the water remains cold. When the electrodes are charged using electricity, an arc is formed at the end. Due to the arc, a huge amount of heat is generated, causing the metal to vaporize. Since the water is still cold, the metal immediately condenses back to solid and disperses to form the colloidal solution.
And in the third method about the dispersion breaking, we are going to talk about ultrasonic dispersion. What is the meaning of ultrasonic dispersion? You would have heard in physics sound waves of high frequency are called as ultrasonic waves. When we pass sound waves with a high frequency, the larger particles will now break down because of the vibration produced into smaller colloidal particles, and they get dissolved in the dispersion medium. So this method, they go for high frequency waves and prepare ultrasonic waves and pass it over the coarse particles, and they will get converted into colloidal dimension. And the fourth method, we have to talk about the peptization. What is the meaning of peptization? Already in a solution, there are huge particles who got precipitated. We call them as coagulated. Coagulated means due to the presence of some impurities, the larger particles of the product would have got converted into precipitated form. That means they are bigger in size. And maybe example, we can take AgCl, silver chloride, as the precipitated material. The size is larger. I am adding purposely an electrolyte like hydrochloric acid. This electrolyte is called as a peptizing agent. So what is the duty of a peptizing agent? Will break this aggregated coarse AgCl precipitate into pieces and convert them into colloidal dimension and dissolve in the liquid. So bringing the precipitated material back into the colloidal solution, we use the term called as a peptization. So dear students, in the first method, that is dispersion method of preparing colloids, we learned about colloidal mill, electrodispersion or Briggs arc method. We learned about ultrasonic dispersion, and in first method, that is dispersion method, we learned 4 types of preparation of colloid. Now in condensation method, as I told you, smaller particles will join together to form bigger colloidal particle. So in condensation, we have 5 methods. The first method is oxidation. So oxidation, you know the definition, either addition of oxygen, removal of hydrogen, or loss of electron. All these we learned in our lower classes. In this method, we are going to take hydriodic acid HiO3. With that, we are going to add an HI. While doing so, you can see this iodine will join with this iodine. Before going for the product, look at the oxidational state of iodine. Here is -1, hydrogen is +1. And in the product side, it gets converted into iodine, a neutral substance. And along with that, we'll get 3 molecules of water. So in this process, from -1 oxidation state, iodine gets converted into 0 oxidation state, that is loss of electron takes place. We talk about the oxidation. During this method, an colloidal solution of iodine can be prepared. So that is condensation method, first method called as oxidation. The second method is reduction. As you know, in reduction we add hydrogen or remove oxygen, or we talk about gain of electron. Let us take example of gold chloride, that is auric chloride, and treat that one with formaldehyde HCHO and 3 molecules of water. If you closely watch this auric chloride molecule, the oxidation state of gold is 3+. And in the product side, it gets converted into Au, gold. There it is in neutral state. So this 6 chlorine will join with the 6 of the hydrogen, and you will get 6 hydrochloric acid molecule. And then this oxygen gets added up, formaldehyde gets converted into formic acid. So thereby you can see the oxidation state gets reduced from 3+ to 0. Then we talk about the process called as reduction. Next method, we are going to talk about hydrolysis. What is hydrolysis? Addition of water and spreading the compound. So in hydrolysis, we are going to take a ferric chloride substance. Whether I am going to add water, I can write the formula of water as H2O, as HOH. And we are going with the 3 molecules of the water. As you know, 3 of the hydrogen will join with the 3 of the chlorine to give 3 molecules of hydrochloric acid. So those 3 OH group will join with iron to give FeOH thrice. So we will be preparing ferric hydroxide colloid. In this process, we add water and split, so it is coming under hydrolysis. The next method is DD. What is DD? Double decomposition. What is the meaning of double decomposition? We take arsenious oxide. With that, we are going to add hydrogen sulfide. The first molecule is going to break down into 2 pieces, decompose. Similarly, the second molecule will break down. So thereby, we will get a product. The sulfur will get attached with arsenic. Then you get an yellow solid of arsenious sulfide in water will be formed. So a colloidal solution of arsenious sulfide, which is beautiful yellow colored substance, will be formed. That is why this method is called as a double decomposition. And the fifth method is nothing but a decomposition. So in decomposition, sodium thiosulfate is taken in acidic condition. When they are adding with acid, the sulfur will get formed as a colloidal solution in water. Sulfur in water type of colloid will be formed. So, we have learned about 5 methods. The first method is oxidation, second method is reduction, the third method is hydrolysis, and fourth one is double decomposition, and the fifth one is decomposition. In all these methods we prepared colloids. The third method, which is printing, is called as the exchange of solvent. In exchange of solvent, if you want to prepare a colloidal solution of one solid dissolved in a particular solvent, you want to prepare it in another solvent, it is possible. For example, phosphorus or sulfur, they don't dissolve in water. You can't dissolve them in water. But phosphorus or sulfur is soluble in alcohol. We have an interesting method. First, dissolve the sulfur and the phosphorus in alcohol, prepare a solution, then you add or mix the solution in water, then you will get a colloidal solution of sulfur or phosphorus in water as possible. That is why they are talking about exchange of solvent. So these are the methods by which we can prepare the colloids. We know little about what are colloids and what they classify and how to prepare them. Now, the biggest disadvantage of colloids is sometimes with the impurities, the colloids becomes unstable. That means in the presence of some electrolyte, the colloidal material will coagulate. That means coagulation. Coagulation means the medium-sized colloidal particles, because of the influence of electrolyte, they join together, become an aggregated material and start precipitating. That means the stability of the colloid is a disturbance now. We don't want this behavior. So, in order to avoid this coagulation, the impurities available, most of the time they are electrolytes. So, the electrolytes have to be removed. For that process, we have to go for purification of colloids. So, main thing for stabilizing the colloids is purification. In purification, we have the 3 main methods. The first method is dialysis. I hope you are familiar with this. And the second method is electrodialysis. And the third method is ultrafiltration. Ultrafiltration. So 3 methods we are going to discuss. Again, this area we can expect in 3 marks, and with the diagram rarely they can ask in 5 marks also. The supportive videos also will add along with us, so that explanation can be easily got from this. And dialysis is the method. What is dialysis? You would have seen some of the sugar patients, if their kidney is not functioning properly, they'll be taken to the hospital, and time to time they'll go for a process called as dialysis. The God's wonderful gift is inside our body. Our blood is having a colloidal condition, and lot of minerals, salts, and sugar, everything is mixed with blood. Our kidney does a wonderful job of removing all the impurities out of the body blood and purify the blood time to time. An unwanted waste material it is throwing out of your body. But sometimes if the kidney is not functioning well, then all this sugar and salt get accumulated in our body, then our body becomes septic and prone to get a lot of diseases. To avoid that, we will go for a process called as a dialysis. What is dialysis? There will be a membrane called as dialyzer. That dialyzer will have a lot of small pores, a semi-permeable membrane, maybe a parchment paper or a leather can be taken. This has the capacity to allow only the solvent, small dissolved solid particles, and the electrolytes can be allowed there, but not the bigger colloidal particles. So the membrane used is called as dialyzer. So by passing this impure blood through the membrane dialyzer, the impurities can be washed away, the blood can be purified. So that method is called as the dialysis.
Hemodialysis. Kidneys are one of the vital organs for the survival. Filtration of urine artificially, other than by kidney, is called hemodialysis. In abnormal or ill health conditions like infections, injury, or restricted blood flow to kidneys will reduce the functions of kidney. This leads to accumulation of poisonous or toxic wastes in the body, sometimes which can even lead to death. In case of kidney failure, an artificial kidney can be used. An artificial kidney is a device which is used to remove nitrogenous waste products from the blood through the process called dialysis. 1. Artificial kidneys contain a number of tubes with a semi-permeable lining suspended in a tank filled with dialyzing fluid. 2. This fluid has the same osmotic pressure as blood, except that it is lack of nitrogenous wastes. 3. One line connected to the artery is connected to the one end of dialysis device, where the blood is collected from patient for filtration. 4. During this passage, the waste products from the blood pass into dialyzing fluid by diffusion. 5. The purified blood is pumped back into the vein of the patient, which is connected to other end of the dialysis device. This is similar to the function of the kidney.
Go for an electrodialysis, that is by passing electricity, electric field to carry out the process, then it is called as electrodialysis. In electrodialysis, there will be an anode and there will be a plate of cathode. In between there are two membranes available, and both the membranes will have pores in it, and the middle compartments will have a pure solvent like water. Suppose our colloid is carrying a cation and anion mixed. It's an electrolyte. So this particular semi-permeable membrane will allow only the anions, and this will allow only the cations. Thereby, because of their having oppositely charged electrodes, they start moving towards the oppositely charged electrode. During the time, the pure water will wash them away from the colloidal solution. So this is an interesting method where within short time that electrolyte can be removed by a process called as electrodialysis.
Electrodialysis. In this method, the dialysis is carried out under the influence of an electric field. Here, the impure sol is placed between two membranes supported by the metal screens. When the potential is applied between these screens, the ions tend to move closer to the oppositely charged metal screens or electrodes. With a steady stream of water flowing through the side chambers, the ions are constantly removed.
The last method is about ultrafiltration. What is ultrafiltration? Let us take for example our coffee. In case some of your relatives is reaching your home and he is looking for a cup of coffee. That time your mother has milk only available for preparing coffee for a single person, and she is adding a coffee powder and sugar and preparing a hot coffee and offering it to the guest. Unfortunately, the guest says, sorry madam, I am having a sugar complaint, diabetes, so I can't take a coffee with the sugar, added with the sugar. Then what to do now? No more milk, and we have to remove only the sugar out of the coffee. It's a difficult process. Then you are coming with a suggestion, use a filter paper or a filter which is available in the kitchen. Your mother is trying. As usual, what will happen? Sugar will come out, coffee powder will come out, even milk and water will come out. No use of this filter medium. Then you can adopt one methodology. Since in that particular filter the pore size is huge, bigger in nature, then we have to add a material called as colloidal. That colloidal is nothing but a jelly material made up of nitrocellulose and alcohol and water. 4% of nitrocellulose and alcohol and water. You add it and make the whole size smaller. They call it as a whisking process. By doing so, when you are adding the coffee now into the filtering base, you will receive water and you will receive sugar, you will receive coffee powder, and the milk particles, the bigger in size, they will get caught over the space. The pore size is very small, they won't allow the milk particles to come down. So by this method, all these things can be removed. Now your mother has to add a little more water with the milk, add now coffee powder alone, warm it and supply it without sugar, the hot coffee to the guest. So this method is called as ultrafiltration. But unfortunately this ultrafiltration is a very, very slow process. So what we have to do, we have to give an external pressure from the top so that the ultrafiltration process can be speeded. Or else at the bottom we have to use a suction pump and remove the air and create a vacuum here so that all the unwanted particles, impurities can be removed at a faster rate. So dear students, today we learned a lot about the colloids, which are very interesting to know, and the basic ideas on colloid, the size, their dimension, their types, and how to prepare the colloids and how to purify the colloids. In next classes we will learn about the properties of colloids. Thank you.